We live in Beirut, Lebanon, which means that we have stunning sceneries, beaches, views. We're always excited to seeing the coastline. However, let me stop you there. There's a huge problem, and that is plastic pollution. As we could look around, we can notice tons of different plastics lying around and categorize them, as well as tiny microplastics particles. We thought, is there any way we can use or investigate in removing microplastics from these wastewater? With a bit of research, we found out that there's actually no method in removing microplastics from wastewater except for filtration, and actually we can't filter wastewater as it's the organic material, and it's a very slow process. Again, a lot of research were made, and we thought there must be a way to remove microplastics from water, as we stumbled across a rock on our shore that had oil residue on the surface of it, where plastic particles were sticking on it, and we asked ourselves, why is this happening? As we then found out that plastics are what we call non-polar, and oil is also non-polar, and as we know in the chemistry, likes attract likes, and well, that's really interesting. We thought if we added vegetable oil to expanses of water, plastic particles may stick on it, and so it did. We tried it out a bunch of different times with various different oils, and we found out light vegetable oils work the best. However, that wouldn't be effective as we would add oil to the environment. Thought maybe we can do our own ferrofluid so we can magnetize our plastic mixture. We did a couple of tests, tried things out, and take a look. Magnetite is Fe2O3 and is a very fine powder that can lead to irritation in the eye and in the lung if inhaled. Therefore, many safety measures were taken while handling this powder.
Ferrofluids are magnetic liquid formed of tiny particles suspended in oil. It is made up of pressed powder mixed with vegetable oil, and in this case, it's the magnetite powder mixed with the vegetable oil. As a secondary method, we use microscopy to examine if any microplastics are left in the water. According to our microscopic observation, very little to nothing was left, meaning water was free from microplastics. To test how efficient our method was, we had to first produce microplastics to remove from the water. The different types of plastics used were hard plastic that were sanded using non-shedding sandpaper and sieved to less than 5 mm. Examples: PET, HDPE, PVC, epoxy, and many more. We also used microplastics that is found in cosmetic products and were separated from the gels using suction, filtration, and desiccation. For instance, LDPE. Moreover, plastic fibers were used from model-making grass, like nylon and polyester, and by removing plastic from the washing machine filter. The extraction process can be summarized as follows. 5 grams per liter suspension was prepared of the desired plastic, done in a beaker with 20 milliliter of distilled water. Also, we added 0.5 grams of the magnetite powder, Fe2O3. The desired amount of oil was also added. We mixed the solution together, binding the ferrofluid to the plastic particles. The ferrofluid containing microplastics was removed using magnets in a small test tube. Then the magnets were pulled out of the suspension. The ferrofluids with the magnetite powder and microplastics were attracted and removed from the beaker. The magnets were dipped into the suspension 3 times, and finally the sample was then ready for analysis.
While conducting these experiments at home, various health and safety precautions were taken. While sanding the plastics, we wore a dust mask, lab coat, and safety goggles to prevent the inhaling of any microplastics and entering of dust into our eyes. In the extraction process, care was taken, and eye and mouth protection were worn when dealing with iron powder due to its fine structure and to prevent inhaling any of it. We cannot disagree that the most efficient way of reducing microplastics in the ocean is by actually using less plastic and recycling them and reusing them in other things. However, in our world, this is a kind of impossible thing because almost every product that we use is made up of plastic. And the main goal here is to control the entering of the plastics into our wastewater and prevent them from entering our oceans. And this is a very hard thing that we lost control over. Do you see the difference? How can we possibly implement an experiment that was done in a small beaker on a very big scale? Now we thought a lot and we came up with a very brilliant solution. What if every government actually implements a rule that every ship, every worldwide ship, should have tubes on the bottom of the ship, and while the ships they are roaming off in the middle of the ocean worldwide, they could actually secrete the ferrofluid with the magnetite, and by this way the microplastics can be cleaned. Once plastics enter our oceans, it is almost impossible to extract them. And the results of this project actually show high potential in resolving a worldwide issue. Now we need the help of researchers and scientists with greater experience and knowledge to help us with further developing this idea.